Arithmetic sequences. The nth term formula. In this sequence, the first term is 5 and the common difference between the terms is 2. So the letter A is used for the first term and D is used for the common difference. The common difference could be positive or negative, it can be decimal, fraction, rational number, irrational, it doesn't make any difference. Same for the first term. There's a formula, which is the nth term formula, which needs to be memorized. And if we substitute our values into this and simplify, we get the nth term formula. To use the formula, put in a value of n, so n equals 1, first term, n equals 2, the second term, 50th term, term k. A simple problem using this formula would be this. Is this value in the sequence? Because the sequence does not stop at 11, it just goes on. So would this value be in the sequence? So we substitute the value here and solve for n, and because n is an integer, and it has to be an integer because n represents a term number, like the first term, second term, third term, 50th term, and so on. If it's an integer, it means this value is in the sequence. Okay, second example. So the first term is 53, and we can see the terms are decreasing. The common difference is -2. We should summarize those values to work out the nth term formula. We substitute them into the general formula for arithmetic sequences and simplify, and here's our nth term formula. So if we want the 99th term, so n is 99, we substitute that in here and here, and then simplify. It's -143. So as the terms are decreasing, which will be the first negative term? So I need to solve this simple inequality. My nth term has to be negative. I have an nth term formula which I use here, and then solve. N is an integer, so it's 28. The 28th term will be the first negative term. So the 28th term is -1. The 27th term was positive. So that clearly shows that when we go from the 27th to the 28th term, we go from a positive to a negative term. This is the first negative term, term 28. Example 3. We have an arithmetic sequence. The third term is given, so n equals 3 and the actual term is 5. The 8th term is given, so n equals 8 and the term is 20. What's the common difference between the terms, and what's the first term? Okay, so the general formula for arithmetic sequences, and if we substitute what we know into this formula, so the actual term is 5, that goes in here. The term there is 20, it goes here. That represents this part. We don't know what a is. We know here n is 3, so that goes here. And we know here n is 8 because it's the 8th term, and that goes here, because we know what n is. And we don't know d, so we have two equations, two unknowns. It's typical simultaneous equations. Okay, we solve to get d equals 3, a equals -1. To work out the nth term formula, we substitute our values into the general formula and simplify. example 4, so the first term here is 4, the last term is 229, and this is definitely the last term. There are no more terms in this sequence. In some sequences, they're like this, it goes on forever, but not this one. This one terminates at 229. So how many terms are there in the sequence? Our focus should be on the last term. This is the term that will reveal the number of terms in the sequence. So we have the nth term formula. We substitute values in that we know. So the last term is 229. We know that a is equal to 4. We know the common difference is 5. So we're looking for n. The n here will give us the n value for the last term, which is the number of terms in the sequence. So we solve and we get 46. So this is the 46th term. I can say that this is U46. This term was U1. This term is U2. First term, second term, 46th term. That's how many terms there are in the sequence. Example 5. The first 3 terms are given in this sequence. We need to work out the value of p. Now the difference between these two terms, so 20 minus 5p, is exactly the same as the difference between these two terms, 3p minus 20. It's always the term on the right minus the term on the left to get the difference. Okay, so we can say the difference is either this, 20 minus 5p, or this, 3p minus 20. And these are exactly the same. So we can make them equal to each other and solve to get the value of p. So these are the actual terms. First term, common difference. Try these questions for practice. Remember, this is from the second year of the textbook.